In this short video, I'm going to discuss the fiber thickness protocol, which is designed to measure fiber thickness and orientation of fibers in optical or electron microscopy images. To launch the fiber thickness protocol, select the Count Size tab and press the Protocols button. Select the Materials group and scroll to the Fiber Thickness Protocol and simply press the Load button. Each protocol includes a set of demonstration images, which may be loaded from the Reset button dropdown and simply press Load Demo. Each protocol includes a default setting of interactive, which allows you to step through the protocol and confirm or adjust the settings as needed for your particular sample. Next, press the Sync button and select the image to analyze, or the image channel if it's a multi-channel image. If your image is already calibrated, leave the spatial set to current. If your images are not calibrated, they may be calibrated using the calibration tool located in the Capture or Home tab, and those calibrations, once created, may be selected through the drop-down located in the Calibrate group. Next, you can draw a region of interest if your image includes a calibration bar in which to exclude that area. To do that, simply press the Create ROI, draw an ROI on the image to exclude the calibration group, and press the OK button in the interactive dialog. Press the next step to continue. At this point, we need to identify the fibers. You can use the threshold, smoothing, and maximum fiber width to define the fibers. Depending upon your fiber sample, you may need to set it to dark fibers, and there's also an option for hollow fibers. To adjust the settings, simply use the slider to adjust the threshold. Once you're satisfied, simply press the OK button. Once you've pressed the OK button, the fibers will be measured, and then there are two measurement types. The first is equidistant. We'll take measurements along the fiber segment, and you may adjust this, the sampling, with a step size of every so many pixels, in this case 20, where we'll take a sample. The other choice is central point, which will take the central point between the fiber segments and measure the thickness there. In addition, for very confluent samples, we can use the Snap to Line tool. What this allows you to do is to click on a fiber and find the perpendicular thickness measurement within that search area. You can see where we're locating those fibers. Depending upon the thickness of your fibers, you may adjust the search radius for your specific sample. And then we can find additional fibers. If there's a location where the search radius may be inappropriate, we can simply press the Undo button and adjust the search radius a little bit to dial that in, and then find the appropriate fiber thickness. Once you're completed the analysis, press the Next Step button and generate the results. From here, we can export the data directly to Excel. The data table also includes a snapshot image. If you'd like to export the snapshot image directly to Excel, please check the drop-down, check the options, and make sure the style is set. The style option allows snapshot images or images to be exported directly to Excel within the data table. If this is unchecked, the image will not be exported. Once completed, press the Finish button. And now you can continue on measuring other individual images, or by unchecking the interactive, you may point to a folder of images to run a batch analysis operation.